on our big low price birthday. Only at ShopRite.
Had a look at the chemical reactions involving our alkali metals. The first reaction we said with oxygen, what was the product? An oxide. When the metals reacted with water, the product was a hydroxide. And when they reacted with one of the halogens, we got a salt. That would be, in this case, if it was with chlorine, the salt was a chloride. No? Okay. Now, I am done with those chemical reactions. The next thing that we have to have a look at is something new, all right? It is the so-called flame test. Now, what they very basically do is, if they have a compound or the pure metal containing a metal, what they're going to do is they go and burn that. They heat it up in a flame. Because specific metals burn with a very specific color of flame. And this can be used to identify which metal we have. So just very simply, it's called a flame test. And if we have a look at the group 1 metals, what they're basically going to do is they use a clean platinum wire. Okay? Now, do you think they are ever going to ask a flame test in a practical exam? If I have to order 10 platinum wires, I am definitely not going to leave them in the school. I'm going to sell them because platinum is very expensive. Okay. So you need to just know the test. They can ask it. The chances of you doing it practical, I don't even think we did it in our first year chemistry at university, a flame test. Because the platinum wire is very, very expensive. Maybe at a mine, for example, at B2 Gold Mine, in their laboratory, where they test the salts, the ores that they dig up to see what type of metals they are, there you might find some platinum wire. All right. Why do they use platinum? It's unreactive. Very important. It can take very high temperatures, and it's unreactive. So it won't melt when you stick it in the flame, and it's not going to react and give you a false positive for whatever. You understand? Or negative. No. All right. So they take a clean platinum wire. It's dipped into some hydrochloric acid. The hydrochloric acid dissolves any impurities on the surface. All right. And then it's dipped. Well, they heat it up with the hydrochloric acid, and they dip it back, and they heat it, and they dip it back until at a point they decide, okay, now the platinum wire is perfectly clean. There are no contaminants on it. Then they go and they dip the platinum wire into the salt sample. Now, what is a salt? It's it's a compound consisting of a metal bonded onto a non-metal. And then they go and hold this compound that sticks to the tip of the platinum wire into the flame of a Bunsen burner. Please remember, we need a noisy blue flame. Is a flame that burns pure. Okay? Yes. Who knows what an oxyacetylene blowtorch is? Yes. If you open up the acetylene, you light the flame. What color flame is there? First, yellow, smoky, ne? And then you open up the oxygen, and then what is it? Can you hear the flame? It goes, ne? A noisy blue flame is a clean burning flame. If I have a yellow smoky flame, it's going to make carbon, which can contaminate or give you a false positive because carbon glows and burns with an orangey flame. Okay, so we need a noisy blue flame, and you will hold that platinum wire that is coated with the salt that you are testing in a flame, and the color of the flame produced will tell you what salt we have. Now, your syllabus specifies you need to know that lithium burns with a red flame. Let's see if I can get some orange. There's some orange. Sodium will burn with an orange flame, and potassium will burn with a lilac flame. If you are asked, or they give you a question, they say an unknown compound, a flame test is done on it, and the color flame you get is red. What metal do you probably have? Lithium. All right. After lithium, sodium is orange, and potassium is purple. Now, potassium is easy to remember because potassium, if we have potassium permanganate, that's the purple crystals that dissolve in water and make the water purple. So potassium is purple, a lilac flame. All right. Lithium, you'll just have to go and remember that one. And sodium, yeah, that one you also have to go and remember because the metals are all shiny metals. All right, silvery, shiny metals. So you can't deduce from what the metal looks like what the flame will be. Okay, so here we have some new information. The flame test. All right. Now we are finished with the group 1 metals. Now the next group that we are going to have a look at are the alkali earth metals. They are group 2 metals. Now, because they are metals, they are shiny, malleable, ductile, sonorous, good conductors of heat, good conductors of electricity. Those are general metallic properties. But what makes them different from the other metals? If we go and have a look, they have got similar properties to group 1. Now, what were group 1 metal properties that were different from the other metals? They are soft. They have low densities and low melting and boiling points. All right. So they have similar properties to group 1. But what do they have different from group 1? They have 2 outer shell electrons. If they have 2 electrons in the outer shell, what charge will they have on the iron? If it forms an iron, it's going to lose 2 electrons. It's going to become positive. Remember, if it loses negative electrons, you are left with a 2+ charge. So all the ions in group 2 are +2 ions, meaning they've got 2 bonding places. No? All right. They form white salts. Now, this is actually quite important. Group 1 elements also form white salts. Like table salt is a white salt. Do you understand? Okay. Now, group 1 and 2 elements all form white salts. The group 1 salts are all soluble. Okay. But the group 2 salts are not that soluble. They are only slightly soluble in water. Okay, so group 1 is more soluble, group 2 is slightly less soluble. The reactions of the group 2 elements in the first case with water, what would the product be when a metal reacts with water? The hydroxide. Okay, remember the group 1 metals. It's general, these reactions, people. If group 1 metals, when they react with water, form a hydroxide plus hydrogen, what must the group 2 metals form? The same. All right. So we say magnesium is very reactive. It reacts very slowly with cold water. You will see tiny little bubbles forming, but it will be fairly slow. But if I had hotter water or steam, the reaction is very vigorous. It happens quickly. Okay? Calcium reacts rapidly with water. Calcium is more reactive than magnesium. Remember on the periodic table, we said what happens to the reactivity of the elements? They increase as they go down. That is why magnesium will react slowly with cold water, but calcium will react rapidly. It's more reactive. Here we've got magnesium and calcium to write the equation. Magnesium plus water must give me magnesium hydroxide plus hydrogen. Why do I write hydroxide like that? You should know. Hydroxide has 1 bonding place. And magnesium has 2. So I need 1 magnesium but 2 hydroxides. And I put the hydroxide in brackets because they go together, the hydroxide part. No. We must balance this equation. One magnesium, 2 hydrogens, 4 hydrogens. Do you agree with me? Because remember, this 2 on the outside means I've got 2 of that and 2 of that. So I've got 4 hydrogens there. Here I only have 2, so I will probably need 2. Now, how many oxygens have I got over there? 2. How many oxygens do I have over here? 2. Now it is balanced. All right? Calcium plus water. Yes, I must also get calcium hydroxide. Can you see? Same formula. Why? These are group 2 metals. They have 2 bonding places. All right? The hydroxide only has 1 bonding place, so we need 1 metal but 2 hydroxides. Plus, which gas do we get? Hydrogen gas. And if we balance it, we will find it would be exactly the same. All right, remember, elements within groups have similar properties. Okay. They say both the formed hydroxides are only slightly soluble in water. All right. You would probably, if you leave the test tube to stand overnight, the next morning there will be a whitish substance in the bottom of the test tube. Okay, that would be the calcium or magnesium hydroxide. That is slightly insoluble. No? The test for hydrogen, we've had that previously as well. A burning splint makes a popping or whistling sound and it burns with a blue flame. That's the positive test for hydrogen. How will I see hydrogen is being formed? You will see bubbles because it's in a liquid. Remember, hydrogen is colorless, odorless, tasteless. So you can't see the gas, but you can see bubbles. And we know if we see bubbles in a test tube, then it implies there is a gas inside it. Okay, so we can catch up the gas and then we can test which gas we have. Slightly water soluble. It does dissolve. You could say, I would say aqueous. Okay, they won't penalize you on that. AQ, water soluble, even though it is only slightly. All right. The next group 7 elements. The name of the group 7 elements are the halogens. Okay? Starting at the top, fluorine, chlorine, bromine, iodine, and astatine we don't work with. What do we know about the halogens? They are all diatomic. They lie in which group? 7. So how many outer shell electrons do they have? 7. If they have 7 outer shell electrons, how many bonding places do they have? From 7 they want to fill up to get 8, so it only has 1 bonding place. All right. So 7 electrons in the outer shell, it forms ions with a charge -1. Why? If it contains 6 electrons, it's going to gain 1, and an electron has a negative charge, so it will have an extra negative charge. Okay, so the charge on the ion is -1 because it has gained 1 electron to fill the outer shell. Okay. Trends in color and reactivity and melting and boiling point. If we look at our periodic table over here, fluorine, chlorine, bromine, iodine, astatine. Can you remember the periodic table has 2 liquids? The one is mercury and the other one is bromine. So we know that's a liquid. What do we know about fluorine and chlorine? They are gases. And iodine is the one that is a solid. So what do we know about melting and boiling point? It's going to increase. Because here we have gases which have low melting and boiling points, and there we have a solid which has a higher melting and boiling point. So there's a trend in melting and boiling point. There is a trend in color as well. Fluorine is yellow. Chlorine is a green gas. Bromine is a red-brown liquid, and iodine are dark purple-black crystals. Okay? So we even find that the color becomes darker. Now, in general, what would you expect would be more reactive? A gas or a liquid or a solid? A gas. For particles to react, the atoms must be separate. Okay, in solids they lie close together, so if I want solids to react, I usually grind it up to make it fine so the particles can be exposed on their surface. Now gas particles are already separate, so gas particles will be more reactive than solid particles. So, reactivity. Fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more reactive than iodine. Which is the least reactive? Iodine. Which is the most reactive? Fluorine. And this is very, very important. Okay, so just let's go and look at our notes here. As you go down the group, the color becomes darker. We go from yellow to green to reddish brown to a purple black crystal. Now, I've written a note in here. Iodine tends to confuse a person. If I have a container with iodine crystals, they are a very dark, almost black color, but if you look at it, you will see it's actually, if you look in the light, it's actually a purplish black color. If I take iodine crystals and I heat them up, they undergo sublimation and the vapor that forms is purple or lilac. All right? The moment I take iodine, now it's not very soluble in water, but it does dissolve in alcohol. If I dissolve it in alcohol and alcohol dissolves in water, then I can eventually dissolve it into water. So a solution of iodine has got a reddish brown color. What's the color of betadine ointment? Brown ointment. Do you know what I'm talking about? Have you seen in the movies when they do an operation, they wash the person's body with a reddish brown liquid? It's a liquid containing iodine. All right? Now, this is very confusing because in biology, when you work with iodine, you work with iodine solution and it's reddish brown. But in the science class, I go and tell you iodine is a dark purple black color. But this is the difference between the crystal, the solid, and the substance when it dissolves in alcohol and water. Okay, so don't let it confuse you. Just take note. Iodine, the crystal, they are purple-black. But the moment I dissolve iodine in a solution of alcohol or water or whatever base, it has a reddish-brown color. And then you want to go and confuse it with bromine, but bromine has a red-brown color originally. Do you understand? Okay, so just take note of that because it does definitely throw you off. Now, the reactivity of the elements decrease from top to bottom. We've already said gases are more reactive than solids, just in general. And we find that melting and boiling points will increase because solids have higher melting and boiling points than gases. So as we go down the group, the melting and boiling point increase. If melting and boiling points increase, what does it tell you about the forces between the particles? They become stronger because to make it melt or boil, you need to overcome those forces. And if it's got a higher melting and boiling point, those forces are stronger. Okay? All right. Now, we must have a look at a couple of the chemical reactions. Now, all of group 7 elements, they like reacting with group 1 and group 2 metals. All right? So sodium will react with iodine, and I will get sodium iodide. Calcium will react with fluorine, and I will get calcium fluoride. Are you with me? We've actually done those reactions when we did the group 1 reactions with the chlorine. Are you with me? Okay? So group 1 and 2 like reacting with group 7. And they form salts. And in general, those salts are white, and they are usually water-soluble. Now, a specific reactivity series exists among the halogens. We've just said fluorine is the most reactive, and iodine is the least reactive. Now, the rule says, and this rule works with metals as well, it says a more reactive element can displace a less reactive one from its compound. Big mouthful. A more reactive element, okay, or rather this one would be a better example. A more reactive element can displace a less reactive one from its compound. So I am going to end up with potassium chloride and bromine. Perfect. There you've got it. Okay. Let's have a look at these reactions. I've just written up a couple of them. Is bromine more reactive or less reactive than chlorine? Less reactive. Is there going to be a chemical reaction? Nope. Why not? A less reactive one can't displace the more reactive one. Do you follow me? Okay. Look at the next one. Here we have got bromine and bromine. Are we going to see a reaction? No. There probably won't be any reaction because the rule says the more reactive one can displace. Not like will displace like. No. Yes. It's just going to stay. This one will have a reddish brown color because of the bromine. Sodium chloride is colorless. This one will also have a reddish brown color. It's not going to change. If we look at this one, bromine and iodine, which one's more reactive? Bromine. Bromine is more reactive. It is going to displace the iodine, and we are going to get potassium bromide. All right. Now, once again, this one is going to be masked a little bit because iodine in solution has a reddish-brown color. Do you understand? Okay. So in solution, you won't really be able to notice the color change. If you look at this one, chlorine and fluorine, can there be a reaction? No. Chlorine is less reactive than fluorine, so there will be no reaction. But over here we will get a visible color change as well. Chlorine is a greenish colored gas. You bubble it through potassium bromide. What's going to happen? You are going to get the formation of bromine, and bromine has a reddish brown color. So your test tube is going to turn from colorless to reddish brown. Okay, potassium chloride is also colorless. Are you with me? This, people, is very important. This rule tells me a more reactive halogen can displace a less reactive halide. What's the difference between a halogen and a halide? No. Or, well, that's what you get in a compound because it's in the ion form. If I have fluorine, that is the halogen. But if I have fluoride, that is the halide. Okay. So the more reactive halogen can displace the less reactive halide. Bromine is going to displace iodine. So we will get potassium bromide and iodine. It doesn't matter in which order you write them. N, A, B, R, yeah, right, okay. Sodium bromide. We can try and balance one. I'm quickly going to wipe the screen. Okay, have a look. We said, will this one react? No. Will this one react? No. Will this one react? Yes, bromine and iodine. We are going to get sodium bromide plus iodine. Okay, now we must balance it. How many bromines? 2. How many bromines? 1. So we will need 2. Okay. How many sodiums? 1, but there we have 2. So I will need 2 over there. How many iodines? 2. And how many iodines? 2. Now it's balanced. You follow? Okay, we can quickly do the transition elements as well. They're not so difficult. Now, the next group then that we have to have a look at are the transition metals. We said they form this group between group 1 and 3, and they lie from period 1, 2, 3, 4, 5, 6, 7. So period 4, 5, 6, 7 contains a special group of metals known as the transition metals. All right? Now, they are not ordered into groups like group 1 and 2 metals. They form a whole horizontal block of elements. They are also known as the heavy metals. Why? What are group 1 and 2 known for? Being less dense, lighter. Okay. So the group The transition group of metals are heavier. They are, in other words, also more dense. They will have high densities. Okay? General metallic properties: shiny, malleable, ductile, sonorous, good conductors of heat, good conductors of electricity. All metals are like that. But what makes them different? They have high melting and boiling points. What do group 1 and 2 have? Low melting and boiling points. Do you understand? They have high densities. What do group 1 and 2 have? They have low densities. Now, another thing, and this we will explain a little bit more when we get to the work, when we do it. If we go and have a look at the number of bonding places, we find very often that these transition metals can have varying amounts. For example, iron can be in the form of iron 2, or it can be in the form of iron. Now, don't worry about that too much. Just sort of take note of this characteristic. We say it has more than one valency. Now, valency is just another word for number of bonding places. Okay, number of electrons that it can lose. More than one amount. Okay. Oxidation state, when something loses electrons, the process is known as oxidation, is a loss of electrons. So we say it can have more than one oxidation state. So copper can be copper 1 or copper 2 plus. Iron can be 2 or 3 plus. Do you follow? When we do specific reactions with metals, we will come back to this and I will tell you. For example, if I have got iron chloride, which one do I have? Well, we should write it more properly. Iron Roman numeral 2 chloride. Or I can write it as, what do the Roman numerals tell me? What the oxidation state is. Or valency is. Do you follow? Okay. You all right with that? All right. Then, valency simply refers to the number of bonding places an element has. They form colored compounds. Copper salts are reddish, bluish green. Iron salts are red and green. Nickel salts are often red. Chromium salts are orange. I don't know all of them. It's just the more well-known ones. Okay. Rust is red, reddish brown. Okay, you get a paint, red oxide, that you paint on stuff to prevent things from rusting. Now, in that paint, there is a more reactive metal than iron. And when the iron starts rusting, it displaces the iron from its compound, so the iron can't rust. Okay. That's on the reactivity series. We'll have a look when we do a topic on metals. We'll have a look at that reaction. Okay, so they form colored compounds. There are some of them that form white salts, but they, in general, group 1 and 2 metals form, all of them form white salts. There aren't any colored salts. Okay, but in the transition elements, mercury oxide, for example, is a bright orange color. All right, so they form colored compounds, and we use them very often as catalysts in industrial processes. Now, part of our syllabus is to do the Haber process. There they use iron as a catalyst, and the contact process is the process whereby we make sulfuric acid. It contains, or they use vanadium oxide as a catalyst. All right, so the transition metals, how do they differ from other metals, or from the group 1 and 2 metals? High densities, high melting and boiling points, form colored compounds and are often used as of elements in the periodic table. But before we start with the new part, I want to have a look. We said yesterday that the group 7 elements, the halogens, they undergo a specific reaction in terms of the more reactive halogen can displace the less reactive one from its compound. Okay, and we did that over there, where we said then that the chemical reactions, they undergo a displacement reaction where the more reactive halogen, that's the group 7 element, displaces the less reactive halide, and we said the halide is the halogen when it's bonded covalently or ionically onto a compound. So we refer to the halide as the one that's in the compound. So the element can displace the ion from its compound. Okay, and I just want to do a couple of examples there, just because it's a new part and it's actually quite important. We said then the reactivity is fluorine, chlorine, bromine, iodine, and we don't work with astatine. Okay, if I gave you a reaction, for example, I said we bubble some chlorine gas through a solution containing potassium fluoride, and we bubble some chlorine gas through a solution containing potassium bromide. What would you observe in the first reaction? Is there going to be any reaction? No, why not? Because chlorine is less reactive than fluorine. Okay, chlorine is less reactive than fluorine. It cannot displace it, so there will be no reaction. Okay, but with the next one that I have over here, if we look on our reactivity series, chlorine is more reactive than bromine. So chlorine can displace bromine from its compound. Okay, so chlorine is going to kick bromine out, and we are going to end up with potassium chloride and bromine. What would you see in this reaction? This stuff is a colorless liquid. What's the change going to be? What's the color of bromine? It's a reddish-brown liquid. So the test tube in which the reaction, or the container in which the reaction is happening, will turn a reddish-brown color. Okay. Is there any questions on that reaction? Remember, we say the more reactive halogen can displace the less reactive halide. Hey, yeah. Because the bromine, here it's bonded in compound form, so it's got different characteristics. It takes on the characteristics of this stuff, and this stuff is a colorless liquid when it's dissolved. So what you've done is you've broken the chemical bond, you've made new chemical bonds, and you've released the bromine as an element. And that element has a reddish-brown color. Okay, and it's mixed. This liquid would be colorless, so it's going to make everything reddish-brown. Hey, okay. All right. Now the next one that we have to have a look at, or the next group of elements, we've had a look at the transition elements. I don't want to repeat anything there. There's nothing strange there. It's just straightforward. The last group that we have to have a look at is the noble gases. What do we know about the noble gases? They form group 8. Sometimes we refer to it as group 0. People, they are unreactive gases. Why are they unreactive? They have so-called filled outer shells. Remember, the first shell has only got place for 2 electrons. The second shell 8, and so on. So they are unreactive because they have filled outer shells. Remember, when atoms bond, they try and fill up the outer shell either by sharing electrons or losing and gaining electrons. Okay? So noble gases are unreactive. They have filled outer shells. They don't have bonding places. They are all gases, and they are all non-metals. Then as we go down the group, we find there's a trend in melting and boiling points. We find that melting and boiling points increase as we go down the group. And we also find that their densities tend to increase as we go down the group. It's actually quite interesting that the trend in density is very often similar to the trend in melting and boiling point. Melting and boiling point is affected by the strength of the forces holding the particles together. If those forces are very strong, the melting and boiling point is high. If those forces are weak, the melting and boiling point is less. But if I have strong forces pulling particles together, they will be closer together. So what happens to the density? It also increases. All right. A more dense substance, not always, but usually you would be able to say that it's got stronger forces pulling the particles together. All right. Sometimes the size of the particle also plays a role, but it's just general. Okay. Where do we use the noble gases? Everywhere where we need an inert atmosphere. Now, where do we need an inert atmosphere? Inert means one that won't react. Now, in airships, you should all know the story of the Hindenburg airship. It had helium in the balloon part, and when it had hydrogen in the balloon part, and during docking there was a spark and there was a leakage of the hydrogen gas, and it exploded and it started burning. So after that they switched and they used, for example, helium in airships or in weather balloons. All right? Why? You see it? Remember, when something burns, it's reacting with oxygen. So if it's unreactive, it's also not going to react with oxygen. So it's not flammable, you can't burn it. Okay, so helium is used in weather balloons. It's less dense than air, so it helps for the balloon to rise up in the air as you take readings with the instruments on the weather balloon. All right? At a certain point, we find when we inflate the balloon here at the bottom, we don't inflate it fully because as it goes up, it gets bigger due to the decrease in pressure on the outside. So helium then is used in airships and weather balloons. There's another reason why we use helium. It's not reactive. Can it cause pollution as such if it's not reactive? No, it can't really pollute anything because it doesn't react with anything. It doesn't affect the balance of anything. Okay, so helium is used then in balloons and airships. Neon, in fluorescent lights, where we need a gas, for example, that is not going to start burning or want to react with anything in the light bulb. Okay, so fluorescent lights, they give off a bright light when current passes through the gas. That's neon. Yes. Slightly at lower pressure. No, there's a powder in it as well. Okay. No, the gas is not the white powder, but it's slightly less than air pressure. Okay. Then argon is also used in filling light bulbs, the filament light bulbs, for example. If I have a light bulb, just a classic shape of the light bulb there, all right, and here we have a filament in it. The atmosphere in this light bulb is not filled with oxygen, but it will contain a little bit of argon. Why argon? Well, if there was a vacuum inside of this bulb, it's going to break very easily. If you just tap it, it's going to break because there's pressure on the outside. So they put gas on the inside so that it is more or less equal pressure. But why do they put in argon? Argon's not going to react. Okay? If there was oxygen in that bulb, what's going to happen to that metal wire? Metals react with oxygen and it's going to oxidize. If it doesn't burn as such with a flame, somewhere along the line it's going to form the metal oxide and eventually the wire is going to break. All right, and then the bulb won't work. So they fill it with argon and it extends the lifetime of the bulb. Krypton and xenon, they are also used in lamps, but in specialty lamps, high intensity lamps. For example, in a flash, in a photography laboratory or studio, they will have lamps that give off very bright light. And that would probably be krypton or xenon inside the lamp. Okay.
I like rhinos. I like them very much. Future here in this area is depending on the tourism. The future generation, they can see and they can benefit from their own resources. Animals like rhinos, elephants, the big five, you benefit from them, and it must be respected. You are not feeding the rhinos, you are not giving them order, so it's a free business.
I don't know.
I think two of my sons, which was little bit 5 years old, they were young guys. So they asked me questions. Why are we here? Why are we sleeping here? I told them this is our resources and this is our future.
My first memory of going with my dad is that I learned new things. As I grow up as a man, I see an opportunity in it. So I decided to look for a job pertaining to tourism. So that's when I was employed at Palembang. So I decided to go for tour guide studies, because I grew up with the tourism industry, the wildlife, the rhinos and everything, to bring that experience to the tourists. You can see the hyena. The biggest change is I was employed, getting paid, and also I can now support my family.
It's a cultural thing. It's coming a long way. Even if you go to area like Treverfontein, area was a lot of paintings. You will see rhino engravings on the rocks. That is an indication that the interaction between human, especially the local communities and wildlife, is dating back. That intimacy relationship is coming for a long time.
We are right here now at Palembang, and Palembang is one of the big lodges in the heart of the desert. And as you can see there is Jumbo standing behind me, which shows it's really a tourist area. We do have elephants, lions, but as you can see, the desert is the heart of the rhinos. This is the main breeding area of the rhinos, is what we found here in this desert.
It's the largest free-roaming population of black rhinos that you find outside national parks in the world. It's a population that communities in the northwest have taken responsibility themselves in managing this population with the structures that government has put in place, more specifically the establishment of conservancies.
These people, before independence, they took it upon themselves and decided that wildlife is our heritage, and through history we've been living with wildlife. And having wildlife in your area is like having a garden.
Because of all these animals, we've got the communities that benefit from all this wildlife, and it's like a triangle that fits into each other. And the communities looked after the wildlife doing their own thing, and the communities benefit.
So already there were this intergenerational relationship between mankind and wildlife, and that bond is what our people actually wanted to see continuing.
Very few countries have the wildlife that Namibia has. What is also important is the policies that Namibia has put in place, which also involves communities to be engaged in the management of the wildlife species and also to benefit from the wildlife resources.
Turn conservation into a rural economy, turn conservation into endless opportunities that would actually cater for those young people that have nothing else to do.
If it was not for rhino economy and tourism in this area, it was really difficult for young people to get or find a job.
We are conservation engineers. We make conservation work in an unfenced area, and through that, we want to turn the wildlife into the rural economy that will benefit the rural communities.
So we can see now wildlife is doing very well, the lodges are doing well, and the community is also benefiting. So it takes all three together.
Devastating hit over coronavirus fears. Airline industry is facing its biggest threat to travel since 9/11.
Since March, when COVID-19 hit Namibia, things actually become very difficult. In the first place, all the lodges closed down because of COVID-19. With us, say the Rhino Trust, we had some donors cutting on their funding. And then we had, in the same time, a poaching case of 2 rhinos that was poaching. We had less boots on the ground, and poachers could actually see. Now it's all changed to go in and do something. So COVID-19 was tough on all of us. Ginger Morning, who is one of our trustees, actually came up with the idea of, why don't we ask you to go to buy some gold for us and make gold bars, and then we sell them for the rhino conservation.
I was fortunate enough to have a chance to have lunch with Clive Johnson, the CEO of B2 Gold in Vancouver, Canada. And I looked at Clive and I said, we've got rhinos, you've got gold, let's do something. Let's create a coin or a medallion or a bar using your resource to create a sustainable source of funding for rhino conservation for the future.
There was it. The gold was bought, the bars was made, and I think it was 31st of January that we launched the bars in Windhoek. And suddenly one morning I had an email from my office, from my finance person, saying, these people don't have salaries. So I said, oh, what now? So I picked up my phone and I phoned Mark Doe. I said, Mark, I've got this problem. He said, but we've got a fund already ready for you. You just have to apply, put a proposal in.
1,000 ounces of gold can make an enormous difference to the livelihoods of the communities that live up there. We are, in essence, providing income and providing a livelihood to the communities. In the absence of tourism, especially now with COVID-19, even prior to that, when we had such a bad drought, the communities became even more dependent on the natural economy.
The idea is to make this a fund that will last for the next 25, 30 years, or even longer. And a portion of that will be distributed immediately as needed. And in this case, the COVID-19 crisis necessitated us to distribute funds to pay salaries to help people in the field.
The proceeds of the sales from the gold bars will be going towards responsible NGOs. And we've identified Save the Rhino Trust as the key NGO. And IRDNC, one of the first organizations that was in the Northwest, integrated rural development and nature conservation, so that ultimately the funds go to the communities and various aspects of their war on poaching.
To be able to support those hardworking men and women that are always in the front line between the poachers and the rhinos.
If it was not for B2 Gold and the golden bars, I think by now we should have been in big trouble.
By extracting the gold, you reinvest it in other renewable resources.
The gold that's coming out from the ground is actually protecting the wildlife that's working on the ground, which is a very good symbol for the others.
I wish this was my bar. This is the 500-gram gold bar. So you'll see on this side you've got the Etindeka Mountains and you've got the mother rhino with her calf. And then on the reverse side we've got the serial number, You've got the Rand Refinery stamp, which is very important. Anywhere in the world, people will recognize the stamp and they will know that this bar contains 99.99% gold.
It is gorgeous.
We wanted to make a biggest contribution. And at Ballowwood, we see that as a way of giving back to the community.
Okay, so there you'll see the 500 gram bar.
Very special.
Feel the weight. It's incredible.
This opportunity which presented itself is absolutely a once-in-a-lifetime opportunity.
We're privileged to have this.
This is just absolutely gorgeous, and I think this showcase really what the project is all about.
It's from 24 karat Namibian gold.
I'm looking at these rhinos is put there like Miss World photogenic, I would say.
There are only 1,000 of these gold bars, rhino gold bars, in circulation.
As far as I'm aware, it's the largest single donation of any corporate to the conservation of biodiversity anywhere in Africa.
Therefore, we so much appreciate and would want to continue as a government to work with B2Gold.
And the fact that it's happening here in Namibia is something that we can all be extremely proud about and very grateful to B2Gold.
Thanks to having this literal pot of gold through the funding for the Rhino Gold Bar, we're able to step in now and make sure that those trackers are supported, and so are their families and their communities.
We make sure that people sustain their jobs going forward, and who doesn't want gold?
And the B2Gold Rhino Gold Bar has come in at a really critical time now, particularly with tourism being closed off and those forms of revenue not coming in.
To say we have the biggest rhino population or black rhino population in the world, let it be for the rest of our lives. And it's that heritage that we have, it's our resource that we can all look after and protect.
It's our heritage. And it's also good that other people like B2Gold are also seeing it that way.
It's actually a very nice link between the investor that buys this gold bar, the rhino tracker in the northwest of Namibia, and the black rhinos. It's an intergenerational thing. The rhino trackers teach their children how to track rhinos, their children get taught, and so it flows down.
This is something that I want my children to have, and that we leave a little bit of a B2Gold legacy. And if I can be part of that as part of my family, I'd be very proud.
It can also become an inheritance for the generations of my own clan. My children, my grandchildren.
If we can bring that passion over to future generations and to hand that over to my children, and I hope that that same passion for conservation gets migrated over to my kids.
And what we've done together is create a sustainable source of funding that should outlive all of us.
You know, I think as far as B2Gold is concerned, we couldn't have chosen a better target in which to put our efforts as far as the environmental and conservation pillar is concerned. And I want to stress there that the money that's going towards environment and conservation is actually going towards the people.
Rhino is for all of us, whether you are in Canada, whether you are in Vancouver, whether you are in the US. If you really want to see conservation at play with rural communities, I therefore humbly request each and everyone to join us on our rhino tour and have a wonderful experience. This is what keeps rhinos on this planet.
I've done rhino trekking experience. It was just amazing walking in that landscape of the Kunene. And as we followed them, we could now find rhinos with the calf. We got the closest distance we could.
It's a warning sign.
And it was just amazing and lovely, something to experience that Namibia can offer. It's something that you have to do in your life.
Thank you.